Okay, this is... What is this? Solving a distance, rate, time problem using a linear equation. Okay, this is solving a distance, rate, time problem using a linear equation. And just like with the value mixture problems, if you watched that video, for these distance problems, I like to use a table to organize my information, and it usually makes it pretty simple for me to figure out what my equation is going to be that I need to use to solve the problem. Whenever you're solving a word problem, the hard part is finding your equation. Once you've got the equation, you know how to solve it, but you've got to go from this problem to the equation, and that's where the table comes in. Two trains leave the station at the same time, one heading east and the other west. The eastbound train travels 20 miles per hour faster than the westbound train. If the two trains are 570 miles apart after 3 hours, what is the rate of the eastbound train? Do not do any rounding. Okay, so the table for these distance problems, across the top, we're going to have distance. Actually, instead of distance first, I'm just going to do rate first. Rate, instead of distance equals rate times time, I like to do rate times time equals distance. That way I can fill in the rate column and the time column, and then I can just multiply across to fill in the distance problem. Or the distance column. Okay. Rate, time, distance, we've got two trains. We've got an eastbound train, so one row is going to be for the eastbound train, and the other row is going to be for the westbound train. The question asks, what is the rate of the eastbound train? So my variable is going to be for the rate of the eastbound train. So I'm going to put x under rate in the eastbound train row. Okay, do we know anything about the rate of the westbound train? Let's see. The eastbound train travels 20 miles per hour faster than the westbound train. So if the eastbound train is x, and that's 20 miles per hour faster than the westbound train, then the westbound train must be x minus 20. No, x plus 20? X minus 20. Good question. Imagine that the eastbound train traveled 100 miles per hour. And that is 20 miles per hour faster than the westbound train. How fast is the westbound train going? 80. So 100 minus 20 equals 80. So x minus 20 tells us the rate of the westbound train, because the eastbound train is 20 miles per hour faster. What do we know about the time? They leave at the same time, and then the last sentence says, if the two trains are 570 miles apart after 3 hours. That means they both have traveled for exactly 3 hours. All right, now we can multiply across to fill in the distance. X times 3 equals 3x. So the eastbound train has traveled 3x miles. For the westbound train, we have x minus 20 times 3. So it's the whole quantity x minus 20 times 3. So we want to put it in parentheses. 3 times the quantity x minus 20. All right, and the two trains are 570 miles apart after 3 hours. Okay, so let's imagine what happens here. Here's the station. One train is going this way. The other is going this way. We don't know how far they each went, and they didn't both go the same amount because one of them's going faster. So one of them must have gone further than the other. But we do know that altogether, at the end, they're 570 miles apart. So however far this train went, plus however far this train went, equals 570. So the total distance is 570 miles. So that gives us our equation right here in this column. The distance of the eastbound train plus the distance of the westbound train equals 570 miles. So 3x plus 3 times parentheses x minus 20 equals 570. So let's simplify by getting rid of the parentheses. So 3x plus 3 times x equals 3x. 3 times negative 20 equals negative 60 equals 570. Combine like terms, 3x plus 3x equals 6x. Add 60 to both sides, so 6x equals 630. Okay, and 630 divided by 6 is 105. So x equals 105. So x is in the rate for the eastbound train. That's what the question is asking. So 105 miles per hour is how fast the eastbound train was going. All right, let's do another one. A long-distance runner starts at the beginning of a trail and runs at a rate of 4 miles per hour. 1 hour later, a cyclist starts at the beginning of the trail and travels at a rate of 20 miles per hour. What is the amount of time that the cyclist travels before overtaking the runner? Do not do any rounding. Okay, so again, we're going to set up our table. Rate times time equals distance. And then our two rows are going to be the runner and the cyclist. The question is asking, what is the amount of time that the cyclist travels before overtaking the runner? So we're going to put our variable in the time column for the cyclist. And what do we know about the runner's time? It says the cyclist starts an hour after the runner. So if the runner was running for 5 hours, the cyclist was riding for 4 hours because he started an hour later. So however long the cyclist was going is x. Add 1 to it to find out how long the runner was going because the runner started an hour earlier. Okay, let's fill in the rate. The runner is running 4 miles per hour, and the cyclist is traveling 20 miles per hour. And then we can multiply across to fill in the distance column. So for the runner, we've got 4 times the quantity x plus 1. And then for the cyclist, we've got 20 times x. Okay, and then what do we know about their distances? Do we have a total distance or what? If the long-distance runner started at the beginning of a trail, the cyclist started at the beginning of the trail. So they both started from the same point. At the end, the cyclist overtakes the runner. That means they both started here at the beginning. The runner started running but was going really slow. After a while, the cyclist comes along and starts riding really fast, and he overtakes or meets the runner at a certain point. So that means they've both gone the exact same amount of distance. They started at the same point, the cyclist catches up with the runner, so their distances are equal. So the runner's distance, 4 times the quantity x plus 1, is equal to the cyclist's distance, and that gives us our equation. All right, let's simplify the left side. 4 times x is 4x, and 4 times 1 is 4. So 4x plus 4 equals 20x. Let's get the x's on one side of the equation. So we'll subtract 4x from both sides, and we get 4 equals 16x. And then divide both sides by 16. And 4/16 simplifies to 1/4. So x equals 1/4. Okay. So X stands for the amount of time that the cyclist was traveling, 1/4 of an hour. And if you look at our look at the box there, it doesn't have a fraction entry. So instead of 1/4, we'll put 0.25. So after 0.25 hours, which is 15 minutes, is when the cyclist will catch up with the runner. And that's correct. And they like you to put 0.25 instead of 0.25. So there you go.